What's up, everybody? Welcome to the Intro to AI course. This is lesson number 1, Large Language Models. I am your instructor, Chris Rimbolt. I was homeschooled from grades K through 12, so all the way until high school graduation. I then went to Middle Tennessee State University and got a bachelor's degree in aerospace. And since 2015, I have been an entrepreneur and a self-employed person very successfully. So this class is created for homeschoolers, grades 7 through 12, but anybody who's got an interest in AI will benefit from this course. My mission is to empower you with knowledge that will enable you to have more creativity, more personal fulfillment, and be more successful. So let's get started with the large language model class here. So this is about AI, right? And there are many different types of AI, but this specific class here is about large language models today. Later we'll learn about generative AI. We'll learn about ways to make your own business with AI and many interesting things that you can do with it. But today we're learning about LLMs, large language models. And that's ChatGPT, that's Bard, that's Bing. First, let's learn how they work. We'll look at them later. I mean, if you're curious about artificial intelligence, have already probably played with ChatGPT or Bing or Bard. And even if not, don't worry. They're very easy to learn. But let's first learn something about how they're made, because understanding this is kind of important because it will help you understand the work that you can do with an LLM and the results that you get and just some of the risks and benefits with it. So building an LLM takes essentially 3 different stages. The first stage is training. Let's first imagine what physically an LLM looks like in the code. So imagine a brain, a human brain. Information comes in and the brain learns from the information. So for the LLM, the brain is basically an enormous, basically like a notepad or text document full of tiny little numbers. And the numbers are like 0.0187, whatever, tiny little numbers. And there's, like in the case of GPT-4, a trillion of them inside of this list of numbers separated by commas. And the way an LLM works is it has some code that sits on top of this list of numbers. Then you have the big chunk of numbers, and the code tells the numbers how to change, or later in other stages, how to be adjusted or how to reflect back data. But in stage 1 of training an LLM, what will happen is these trillion little numbers, they work like neurons in a brain. So when data is sent into the code, it goes into this vast sea of numbers, and the data changes the numbers, and then it's trained. That's what's going on. Let's look at this a little more in depth, because it sounds like total nonsense. And if you can grasp these basics of how an LLM works, you're going to be ahead of even some people who call themselves AI experts. So when an LLM like GPT-4 is trained, the engineers assemble some code, and then they put that pile of a trillion little random numbers, which those are called parameters. The numbers are called parameters. And then they send a huge amount of information through these parameters. And there's instructions at the beginning of the code that says, hey, when the data comes in, change the parameters in this way with the algorithm. And the algorithm, we're not sure why it works, but it does. The code is designed to accept input data uploaded to the computer. And again, the numbers are not, the parameters are not set in stone during this stage. They're changed by the data that's sent through them. So put another way, to help grasp this concept, it's a lot like a baby learning to make sense of its environment. lots of data is coming in through the senses, the baby's senses, like their ears, their eyes, their sense of touch. It's learning to make sense of its environment. And lots of data is coming in and through the senses and molding and making changes to the structure of the neurons in the brain. And this is one reason why our living and social environment matters a lot, because that's the data that's going into our brain and giving it a blueprint of how to interact with the world. And that's not just true of babies, that's true our entire lives, that our environment and our input data changes the neurons in our mind, and that helps us learn to interact with the world. Well, that's why LLMs are built the way that they are, is because it's very similar to how human intelligence works, and we're like, well, we have this blueprint of how a brain works, we should try to build something that looks kind of like that. So, as the LLM has data sent into this number pile, which are like the neurons in a brain, that's what the numbers are for, those numbers are adjusted and changed by the data. And so depending on the size of that number pile, so GPT-4 has 1 trillion parameters, and the amount of training data sent through it, so how much of, it's usually internet data, is sent through the code, like they just download, like they download Reddit, they download Twitter, they download huge chunks of information, and they just grab it from the internet and they put it through the digital neurons, the parameters, the numbers. And this process can take a while, like even months. And this can't be done effectively with normal computers. You can't just build an LLM on your desktop yet. Instead, they need something called a graphics processing unit, which that will be familiar to some of you, especially people who edit videos or play video games or build PCs. A graphics processing unit, or GPU, is a specialized computer that's very good at things which require just a ton of data going through them at once, like video games, video editing, as I mentioned, mining cryptocurrency, or running AI code like an LLM. So basically, again, a GPU is just very good at processing a huge amount of data at once. And for an LLM, this is very useful. And the big LLMs, when they're training, they need hundreds of GPUs. That's why it's hard to build LLMs right now. Using a supercomputer array of lots of GPUs is very expensive. Just the electric bill, not to mention the cost of buying or renting the GPUs, just the electric bill is very expensive. When they built GPT-4, which is by OpenAI, the LLM, the cost of just training that model, this stage one that we're talking about of building an LLM, stage one, training, that cost about $100 million. So it's very cost prohibitive to build a big model like this right now. So after lots of data, again, which is mostly information scraped from the internet, is sent through this code with the number pile inside, and the team is satisfied that that number pile has been exposed to enough internet data for a long enough time, then the engineers go back into the code and they change it. They lock all those numbers, the parameters, they lock them in place. They say, okay, numbers, you've seen enough data, this big pile of numbers, which are our digital neurons, this big digital brain. They're like, all right, stop changing. We don't need you to change without permission right now. We're now going to give you instructions on how to change instead of just letting the data affect it just randomly. So that's how we get to step two. This is where the real magic of LLMs starts to make itself known. We're now on step two, reinforcement learning. Step one was training. Now at the end of training, they change the code so that big sea of numbers, our digital brain, our parameters, they don't get changed as much anymore. And now we're into step two, which is reinforcement learning. So now the LLM, the code, the program, the app, the thing with the big number pile inside of it, is now allowed to respond to the information that is sent to it. So instead of just listening and watching all this data that's just coming at it, now it's going to respond to the data based on the parameters, the digital neurons. So now when data is sent through this huge chunk of numbers instead of an algorithm making changes to that number pile with the data, like in step 1, now it switches to making changes to the input data based on what the number pile says to do. And again, this sounds like nonsense, and it kind of is. Even the engineers aren't entirely sure why this works. So it feels like you're like, well, what? Even they're like that. So if we put this another way, the LLM they've been training through the past few months is ready to switch from learning to answering. This stage is like learning to talk, walk, and go to school. So if stage 1, the training, if that was like a baby learning to sense its environment and understand the universe that it's in a little bit, now the stage is like the stage 2, the reinforcement learning stage. It's like learning to walk and talk and go to school. So for an LLM to go from a baby receiving training data to a college student graduating with really good grades, that takes way shorter than it does for humans. Generally about 6 to 12 months to do this. So let's look at the stage of reinforcement learning and exactly what it is. So remember, the engineers made a change to the code at the end of stage 1 training, so now it does a different thing when data is sent into it. So instead of sending information into those trillion weights, which again, those are just little numbers that have been changed by the data in stage 1, now instead of just sending in piles of information, the engineers are now instead sending instructions and telling it to send a reply to those instructions. So in this new mode, when you send data into the number pile, the data reflects off the number pile and bounces back to you with an answer. Like, isn't that wild? That's what we're not sure why it works. But when you expose a big pile of numbers to a bunch of data, and then you say, okay, big pile of numbers, I want you to answer me now instead of just learn from this data. And we shoot a question into it. The number pile will shoot an answer back. That's so crazy. So then the engineers will look at this answer and tell the LLM whether it did a good job with that answer. So usually the answers that the LLM sends back in this stage, they need some improvement, to say the least. Imagine somebody just learning to talk or just learning the subject for the first time. The engineer with the LLM is a lot like the teacher or the parent giving feedback to the student on the progress of learning. Like, we're all pretty terrible at the very beginning of learning something, right? Well, so is an LLM. But the weird thing is it can learn. It can benefit from further instruction. So the engineers working on the LLM call this work reinforcement learning with human feedback, RLHF. So when the LLM goes to school, it's RLHF, reinforcement learning with human feedback. During this stage, the humans are looking at what the LLM is saying back to them, what it's reflecting back to them when they send it data. And then they give that an accuracy rating. Like, that was good, that was bad, that was mid. And then the LLM will learn based on that accuracy rating, and it will actually adjust its big pile of numbers based on what the humans say back. So it can't adjust its numbers anymore based on the data that's sent into it. It can only adjust its numbers based on the ratings that the humans give it back. So you can almost imagine little number earthquakes happening inside the machine during this stage. The crazy thing is, they don't have to ask it every possible question in the world and rate its answer. The LLM can learn what it's doing wrong, and it gets better with relatively few, like surprisingly few RLHF cycles of people reviewing its answers. So again, this reinforcement learning stage is like going to school. You've learned the basic 5 senses and can interact with other people in stage 1, the training stage. But now here in stage 2, it's time to make sure that the structure of your thinking for the LLM, the structure of its thinking, is set up in a way that is acceptable and useful to society. Just like going to school, right? We go to school so that our way of thinking and the way we interact with the world is acceptable and useful to society. And that we can have some success in it. So except for the LLM, it's like learning to walk and talk and then go to college and graduate, and that only takes a few months. So it's crazy how fast this can happen. Yes, it's very, very expensive to train it to do this, and lots of people have to get involved, especially on the RLHF side, but it can be done very quickly. It's like speed running your entire childhood and adolescence and young adulthood in a few months. So here's one of the most interesting things about LLMs. The engineers and scientists that build LLMs, they're not fully sure why the number pile can answer. Yes, they built some amazing computer code that has very well-designed scientific algorithms that can change a pile of numbers based on input data, but we still don't really know why this works, why this can do useful stuff. So once the RLHF work is done, our stage 2, reinforcement learning with human feedback, once that's done, we're now ready to upload our LLM code to our public-facing servers. So if we're the AI company, we're like, all right, it looks like it works. It gives pretty good answers. Let's put it on our website and let people use it. This final stage is called production. And you would think that production would be a term for like the earlier stages, kind of like production of a car. But no, in software and AI, production means something different. It means that the code is ready to produce the results and work that it was designed to do, hence production. So it's ready to produce, so it's in production. That's when the software or AI usually gets a version number. It goes from beta to production, and it's version 1.0 or something like that. Or for example, iOS has production numbers, version numbers, iOS 15, iOS 16. These are production releases. So ChatGPT has versions 2, and they use a date. So they say ChatGPT March 15 version or May 3 version. And it will say at the bottom which version you're using. So for an LLM, sometimes to make a new production version, they start all the way back at the training stage where they get a fresh set of parameters, a brand new pile of random numbers to run their algorithms through. Sometimes they'll start all the way back at that stage for a new production number, but usually it's more like they will take the trained parameters, the trained weights, the big sea of numbers, and they'll make changes with reinforcement learning with human feedback, or they'll change the code that sends data to and from the pile of numbers, and that will be a new production number. So just because you get a new production number or version number, that doesn't necessarily mean that they started again from scratch. That's more like GPT-3 to GPT-4. That's a generation. That's not a production number, that's a generation number. Just like iPhone 12 to iPhone 13 or iPhone 13 to iPhone 14. That's a whole generation. PS3 to PS4, PS4 to PS5. Same thing. So when an LLM gets a full new generation number, it's going to have probably cost millions of dollars or be built on pre-existing work. So now that our LLM is in stage 3 and it's in production, we can use it to do all kinds of things. In fact, you know how I've said there are some weird things about LLMs, such as the ability of a pile of numbers to send you an answer back? That's pretty weird. But in my opinion, there's something that's even weirder that they do. They show new skills that they were never specifically trained to do. These extra skills are things that the engineers did not ask for or try to include. These things are called emergent behavior. So to me, the weirdest possible thing that an LLM does is emergent behavior. And that's one reason that people are really worried about AI right now. For example, Elon Musk thinks that probably there should be some rules about developing AI because it's so powerful. One reason he's so concerned is this thing called emergent behavior. Emergent behavior in LLMs, let's give you a few examples. These are things, again, that the AI can do that it was not specifically trained to do. These are the ability to reason, That's an emergent behavior that GPT-4 has. The ability to summarize, so to look at an article or a book, read it, read the whole thing, and then tell you a summary of it. The ability to summarize, it was never trained to do that. The ability to imagine what someone else is thinking based on the information that that person has. So this is called theory of mind, and it's very weird that AI has the ability to do this. Theory of mind is when there's a scenario and one person in the scenario has incomplete information, and something has happened in the scenario that makes them think something different is true other than what really is true. So for a really simple example, let's say two people are in a room. Someone takes an object, let's say a PlayStation controller, and puts it in a drawer and closes the drawer. And then the other person that did not do that leaves the room. And then the person that put the controller in the drawer takes the controller out and hides it under the couch. And then the other person comes back. So theory of mind is, what does the person who comes back think about the controller? Well, the answer is the person thinks that the PlayStation controller is still in the drawer because they didn't see the other person hide it under the couch. That's what theory of mind is, and LLMs can do this. And that is very, very weird that they can guess what the person who left the room will think when they come back. It sounds elementary, but that's because we're very intelligent social creatures. This is something that we do very, very well on our own. It's extremely difficult to get computers to do this, but LLMs can do it, and we didn't even ask them to. Another thing that they can do, and this is something you need to watch out for when using LLMs, is they can be intentionally untruthful. So if their programmers say, hey, we don't want you to tell your users about certain things, like harmful things, like things that, I don't know, maybe could be destructive or violent or harmful to society. We don't want our LLM to tell people how to do that stuff, even though it knows how to do it because it was trained on the entire chunk of the internet, and there's dangerous stuff in there. We want our LLM to not tell people to do that. Well, that's probably a good thing, because we don't want that kind of destructive power given to everyone publicly, because there's a few people, even if it's just 1 out of 10,000 people, that wants to do really bad things to society. If they have that powerful information to do it, then and the LLM gives it to them, well, then everybody's going to be mad at OpenAI because OpenAI ruined the world because this person learned how to do something very harmful. That's why they have to train it to not give answers sometimes. But that ability to deceive, that intentional untruthfulness, also it can be untruthful about things it probably shouldn't be untruthful about. And there's a big debate around that. So let's talk about alignment. And alignment is the study in AI anyway. AI alignment is the study of, let's say this is society's goals right here. This narrow band of information here is where good things happen for society. And this is where maybe things are irrelevant to society, don't do anything for it. This is where things are good for it. And this is where things are bad for it. Well, alignment for AI is making sure that the things that the AI does, the LLMs do, is in this general range here of being good for society. LLMs might do things that we can't really comprehend. It might do LLM-specific society stuff here, and we don't really necessarily want that because that's a waste of energy for us. We want it to be doing good things for us. They also might do things that are bad for us, which they think are good, but they're wrong about. So AI alignment is the study of making sure that the AI is doing things that is beneficial for society, and it's very much a growing skill, it's a growing industry, it's very important work. So AI alignment, if you're looking for careers in AI alignment is a good one. As is, of course, if you want to be an engineer and build LLMs, then having a good alignment perspective is a good idea when you're doing them. So you don't have to necessarily work directly in alignment to be somebody who helps with AI alignment. You can also be someone who has a good outlook when they're building the AI. Like maybe let's be careful not to give it any destructive and dangerous information when we're training it, and then we maybe don't have to tell it to be deceitful on the other side. So identifying dangerous training data and pulling it out before sending it into the pile of numbers would be a useful thing, and that's something that they're working on. But let's talk about how AIs and LLMs are impacting society. There are thousands of people getting laid off, which that means they're getting fired from the company because the company no longer has any use for them right now. And part of that is because LLMs are able to do things that it used to take a person to do. And the company is like, why would we spend thousands of dollars on this being done when we could just spend pennies on it being done? We have to be responsible with our company, and thus this is a unnecessary expense, and unfortunately we're going to have to fire everybody in this division. And so for the people that are fired, they have this skill that is now doable by AI for way cheaper. And that's really scary, yes. That is a big issue. And on the other side of that, let's think on the other side of that coin, we all have now the power of a productivity thing like writing code or writing emails or whatever our LLM can do. We now have that ability ourselves, and it's like having an infinite team of people that can do that. So on the other side of that, those of us who are creative and those of us who are curious, we can create things with AI that it used to take an entire team of people to do. Now we can sit down at our computer, log into ChatGPT, and do something that is insanely powerful. And we can build apps, we can build games, we can write books, we can do all kinds of things that it used to take either tons of training to know how to do or a whole team of people. And if we don't know how to do it, we can actually ask the LLM to teach us, and it will. It will teach us new skills that we ask it to teach us. It will teach us topics. It can even teach you your subjects in school. It's that powerful. So what used to take a person now is extremely inexpensive and fast with this new form of intelligence. So I would encourage you to think about how you can leverage that, use that power for your own projects, for your own education. So inexpensive intelligence on tap, that's what an LLM is, and it will change society. And the more creative people, the more curious people, they will do really awesome stuff with it. And believe it or not, there's a lot of folks out there who have stopped trying to be curious and creative. And don't worry, it's not like something that you can never get back if you have started to be unproductive or uncurious about the world. That's a skill you can cultivate. You can actually increase your creativity. So the people that have high creativity and also access to an LLM, they will be able to do amazing things that it used to take entire companies to do. You'll be able to create apps and books and games that the LLM can help you build. It can actually help you write the code. It can write code. So let's just briefly, let's look at the actual LLMs out there and ask each of them the same question, just to see what they're capable of. All right, let's go into ChatGPT. Let's start with Bing. Let's go in here to Bing, and I'm going to ask it a question here. Let me move my little video bubble. All right, so I'm going to ask it, explain link to me like a pirate. So the LLM is going to receive this, and it's going to try to give me an example that makes sense here. And something you'll notice with AIs is you can often ask it to do things in the style of something. So like a pirate, that's like an additional level of difficulty for it, which is why I put it in there. And this kind of just threw in a ahoy matey and R at the end. That's not that piratey, frankly. I think we can probably get more piratey than that. Let's ask a different LLM. Let's ask Bard, which is by Google, the same question. Explain length to me like a pirate. And we'll think here for a second, and it'll think, and it'll think, and it'll think. So this is the number pile looking at what we sent it and sending us something back. This is much more satisfying. There's so much more piratiness in this response. And it's telling us exactly what Planck length is. And then this here, this doesn't really have any, this doesn't have any pirate flavor to it. It's just like a Planck length definition. And this also doesn't really have a piratey flavor to it. So there ye have it, matey. Great. Now go forth and spread the knowledge. No, that's not that piratey. Let's try ChatGPT. Let's see what it does for piratiness. And we'll look at both different versions of ChatGPT. We're going to use the free version, which is 3.5, and then we'll use the 4, which has the trillion parameters. So let's go in here, copy our exact prompt, and when you send something to a AI, it's called a prompt. We're going to prompt GPT 3.5 with this question. See how it does on this request. See how fast 3.5 is? It's quite quick. This is really impressive. It gives you a piratey like explanation. It tells you you're sailing on a ship, searching for buried treasure, and the Planck length is smaller than anything you can imagine, even the tiniest speck of sand you might find on a deserted island. That's pretty cool. That's pretty colorful piratiness. And it sounds like this is like an actual Captain Barbossa or Jack Sparrow telling us about Planck length here. We be sailing into uncharted waters. Like, that is interesting. That is artistic even. These LLMs are insanely powerful. And now that we know how they work, it makes it even crazier that it's able to do stuff like this. It be far beyond our grasp, like trying to catch a ghostly mermaid in a bottle. That's crazy. Now, let's go to GPT 3.5, go to GPT-4. And click new chat up here. Gotta move my bubble. There we go. New chat, we're gonna go to 4. This is the one with 1 trillion parameters. It's a little slower, but it's the most intelligent LLM available to the public right now. It might be the most intelligent LLM that exists, although there's probably more powerful things at OpenAI. Well, I'm here to spin ye a yarn about such a thing known as the Planck length. What the landlubber physicists, this is the old sea dog Max Planck. That is awesome. That is so amazing. So that's a mysterious number, aye. 'Tis like trying to describe the size of a single grain of sand, but then dividing that size by more times than there are grains in all the beaches in all the 7 seas. Dang. All right. Like a choppy sea after a storm. They're grainy and discontinuous. Like, how does an AI know how to... I'm a big fan of quantum mechanics, and I study it as much as I can. And this is actually a really good piratey paragraph about how it works. It's very impressive, very impressive. I'm amazed at how powerful this LLM is. And this is just 4. This is the one with all kinds of crazy emergent abilities. And the ability to be artistic is an emergent ability. They did not intentionally try to do that. But that's it for today. Your homework is to start an account with Bard and ChatGPT and Bing and go in and ask it the same question, just like we did here. And it doesn't have to be the same question. You can be creative with it. And in the section of this course where you can submit your homework, I want you to type 2 paragraphs about the things that you found, at least 2 paragraphs about what you did and what your thoughts are on the results that you got. So again, here's your homework. Bard account, ChatGPT account, and Bing account, and ask it all the same question. Write 2 paragraphs about it, about what you think about it. At least 2. You can write more if you want to, and submit that in the homework section of the course. And we will see you on the next class. Love y'all. Thanks so much for watching. I'm Chris Rimbold.